Today we're doing section 2.6. Our objective is to analyze vertical and horizontal translations, which will make more sense in a moment. All right, a translation is an operation that shifts a graph horizontally, vertically, or both. So we are shifting or sliding a graph. It results in a graph of the same shape and size, just in a different position. A parent function is the simplest function with the given characteristics. For example, y equals x is the linear parent function. Y equals the absolute value of x is the absolute value parent function. Vertical translations. A number added or subtracted outside the absolute value bars or at the end results in the parent function being shifted up or down. So if y equals the absolute value of x plus k, then a k value that is greater than 0 or a k value that is positive would translate it up, and a k value that is less than 0 or negative would translate it down. All right, on example 1, we have the parent function y equals the absolute value of x, and then we have a translation, the second function, y equals the absolute value of x minus 3. So we are supposed to describe how the graph of the second function relates to the first. So in most of these cases, it'll be something like shifted up however many units, shifted down however many units. On the next page, we'll start getting to shifted left and shifted right as well. So on the first one, we would say that it's going to be shifted down 3 units, or you can just put down 3 units. Our next task is to graph them. So I'm going to see if I can switch my view to a graph paper. We'll see how this goes. I like the medium. Okay, so let's take that away. All right, so I need to set up my coordinate plane, and then I'm going to be graphing those. So I'll put my coordinate plane in here. We'll just see how this works. So as a reminder, I'll write it down here that I'm graphing y equals the absolute value of x. I am also graphing y equals the absolute value of x minus 3. So these are the two things I'm graphing here. This is from example 1. Let's start with the parent function. Pretty soon you should be really fast at graphing these parent functions. From yesterday, what shape should this graph have? A V. Yesterday we learned absolute value ones have a shape of a V. Now yesterday we went through finding the vertex of it using the M, B, and the C, right? What is my B in this case? What's being added or subtracted right behind the x? Nothing, and in math we call nothing 0. Okay, so if my vertex is going to be 0 over 1, that's just 0. What am I adding or subtracting outside? Nothing again, 0. So my vertex for this one is at 0, 0. Pretty soon you're going to have it memorized how to graph the parent function. You won't have to go through all these steps. Yesterday we also used m as our slope. What is my m for the parent function? 1. So that means I can go where from my vertex? Charles?
I have a question.
Okay. So we use slope as rise over run. So yesterday from our vertex we would go up one, right one, up one, right one. So I can do that here as well. But I talked about that only gives me half of my graph. Where's the other half going to be? To the left of all of these, right? So it's all symmetric. So I can go up one, left one, up one, left one, up one, left one, and get my other side. So then I would graph that line. And I would do it on both sides. Like so. Okay, put my arrows on it. Great. So I have the parent function graphed. But we still need to graph the translation, the one down here. But we just talked about that this graph is going to be shifted down 3 from what the parent function is. So if I have the parent function, I don't need to re-find my vertex and do all that stuff. I just take any point that was on the parent graph and move it down 3. So my vertex, I'm going to move it down 3. 1, 2, 3, plot a point. Okay, this point, the points that I found using my slope, I'm just going to take them all and drop them down 3. 1, 2, 3, put a point. Put a point. Put a point. Do the same thing on the other side. Drop them all down 3 to get your other points. And again, we can see that we have a V. And we should be able to draw our lines in nice and straight. Okay. Put our arrows on it. And then we're done. We graphed both the parent function and the translation of it being shifted down 3 units. Alright, on example 2, we just have y equals x. What is that graph going to look like? Positive, yes. It's the linear parent function. So the graph is just going to be a line. I know we did a lot of V's yesterday, but this does not have absolute value bars. So this is just going to be a line, which means this one, the second function, is also just a line. But we can still tell how they're going to relate to each other. So again, we would say it is shifted in what direction and how many units. It is shifted up 5 units. So for how it's related, we would say up 5 units. We will graph it. We just first want to know how it's going to be shifted. Now this one, you don't need to use the parent function to be able to graph it, right? We were graphing stuff like this last week, the week before. But we'll go ahead and use the parent function idea since that's what our lesson is about today. Back to the graph paper. All right. So I am going to be graphing y equals x and y equals x plus 5. Graphing linear ones should go a lot quicker for all of us because we've had more practice with them. I would recommend graphing using your slope and y-intercept. And somebody I have not heard from, raise their hand and tell me what my y-intercept is for the parent graph. Keaton, what do you think it is? 0, 0. So that's where my first point would go for my parent function. And then I will use my slope. Alexis, what's the slope? 1. So we go up 1, right 1, up 1, right 1, so on and so forth. Get a few points. We're able to make a line. Remember, these ones go in both directions. So I'll try to make it a little longer. Linear functions go in both directions instead of just being a V shape. And then we talked about the second function is going to be shifted in what direction? Up 5 units. So I could do my y-intercept again and my slope again, or I could just go to the points I already have and go up 5. 1, 2, 3, 4, 5, put a point, up 5, up 5. I'm getting towards the edge of my graph paper, but that's okay. Any of the points down here, I could shift those ones up also. And I should be able to create another line. There it is. That goes through there. On number 3, we have a parent function of y equals the negative absolute value of x. What would that graph look like? Very good, Charles. An upside down V. And then we have the second one, y equals negative absolute value of x plus 4. Can someone that I have not heard from yet today tell me which way they think it would be shifted? Ajaya. Up 4. Very good. So we would go up 4 units. The negative sign out in the very front, that just means it's going to be upside down, an upside down V. It has nothing to do with the fact that we're still adding 4 at the end of the problem. Okay, let's go back to the graph paper. That's not an eraser. There it is. All right. From our parent function, y equals negative absolute value of x.
Well, it's only 0, 0, but the end would be negative 1. Or negative down 1.
Good. So yes, so our vertex is still going to be at 0, 0. So the vertex here is still at 0, 0. But like we talked about yesterday, we know that this one has to face down. So even though our slope is still 1, we've got to go down 1, right 1, down 1, right 1. And again, that will only give us one side of it. So to get the other side, we reflect it over. We go down 1, left 1, down 1, left 1. I'm expecting that graphing the parent functions should be something you're getting quicker at as we go. That's why I'm not spending as much time graphing the parent. Okay, and we talked about the second function, y equals negative absolute value of x plus 4 is going where? Up 4. So I can take any of these points I just made and take them up 4 units. 1, 2, 3, 4, up 4, up 4, go to the other side, up 4, up 4. Just counting up 4 from each of them. And then I can put in my straight lines to make my V. And I'm finished. So we can see that it was shifted vertically, shifted up 4 units. Remember from our notes at the beginning of this that we were talking about y equals the absolute value of x plus k. Or you could think about y equals x plus k for linear. So this would be absolute value, this would be linear, but the k is what's coming at the end. All right, so on number 4, Grace, what do you think our parent function is? Grace? Y equals, so we go back to the front. We noted what our parent functions were with those bullet points kind of in the middle of the page. the absolute value of x. So that's our parent. That's our mama function. There's our parent. Then we also have to identify k. Caden, what is k? -1. Very good. So that's all we're doing on these two problems. Identifying the parent and identifying k. On number 5. Not here. Lanaya, what do you think our parent function is? Close. We're going to strip back that 3 too. We're going to take it all the way back to just y equals x. So our parent is the most basic it can get and still have the correct shape. So our parent is just y equals x. Our k value, India, is 5. So you might be thinking to yourself, what about that 3? Okay, it just doesn't apply to either of the questions that we were asked. Technically what the 3 does, and I'll have to see if we get into this later, the 3 stretches the graph. Stretches it out. Oh, you know, I'm kind of changing my mind a little bit. I would accept if you were to put a 3x here. I would accept that, because we would want it to have the same stretch. So the most basic parent function, I think usually you're just going to put y equals x. We're not talking about stretching today, so it's kind of unfair that they threw that 3 in there, in my opinion. On 6 and 7, we are writing an equation for each translation. So we're starting out with y equals 2x. And we want to write an equation that would show that shifted 4 units down. So I know the first part of my equation should just be the same thing, y equals 2x.
Y equals 2x minus 4.
-4, very good. The -4 at the end would show that we're shifting it 4 units down. That's it, easy peasy, nothing too complicated. On the next one, again, this whole absolute value of 1/4 x, that's not changing. But if I want it to move a half unit up, John, what would I do to the end here?
Put plus 1/2 up.
Beautiful.
Put plus 1/2.
Yep, if we just put plus 1/2 at the end of it, that would show that I want to move that graph up half of a unit. For horizontal translations, this is when we're moving left and right. If h is a positive real number, then y equals the absolute value of x plus h with h inside the bars translates that parent graph h units to the left. Now this is why this is not so intuitive, because usually we think of adding going the other direction. Okay, so this is counterintuitive. Up and down, that was intuitive. Horizontal, going left and right, it's counterintuitive. I'm sorry, it's backwards, it's weird, we hate it, but we just have to be able to remember it. So then if we take x minus h inside the absolute value bars, that is when we are going to be moving it to the right. All right, so let's start out with describing movement. So again, if we are adding or subtracting inside the absolute value bars, we're either moving to the left or to the right. Emily says we are going to the left, which I agree with. We are moving to the left how many units? 3 units. Okay, so again, our parent function, we should be able to graph that like without even thinking about it now. And then we're going to take those points and move them 3 units to the left. All right, You should be getting close to being able to graph the absolute value of x in your sleep. Where's my first point going? 0, 0. We're at the origin. Where are my other points going? Up 1, over 1 in both directions. So up 1, right 1, up 1, right 1. Also up 1, left 1, up 1, left 1. And we put our lines. We make a V. It is so pretty. There we go. All right. So that was fun. Now we are going to move these which way? To the left, right? I think somebody said last time we're pulling a Beyonce in here. So we're going to the left 3 units. So I take my vertex, I go to the left 3 units, 1, 2, 3, put it point. Now these graphs are going to overlap each other. That's okay, they're supposed to. So I take this point here and I go 1, 2, 3 units to the left. I would just like put your pencil on your paper and start counting. This point, 1, 2, 3 units. You can do it with your other points. 1, 2, 3 units. 1, 2, 3 units. Right. Our shape should look exactly the same. It's just going to be moved over. So if you all of a sudden have a V that looks like it's way narrower or way wider than the first one that you made, something probably went wrong. It should have the same shape, just be moved over. All right, again on number 9, the negative sign out in front of the absolute value bars is not shifting it left, right, up, down. It's just flipping the whole thing. So this is going to be an upside down V. But then we go look at the second one. Inside the bars we have x minus 2. So which way is that going? Nope, to the right. Remember, inside the bars, it's backwards from what we would think. We're going to the right, how many units? 2 units. Okay, so we are going to be graphing y equals the negative absolute value of x and y equals the negative absolute value of x minus 2. Let's start plotting points. On my parent, or my first one, where's my origin? Or sorry, where's my vertex? The origin. Okay, gave that one away. All right, and this one, instead of going up 1, left 1, I'm going to go down 1, right 1, down 1, left 1 to get my points. It's an upside down V. And I can go ahead and graph it. I would recommend going ahead and graphing this one before you start doing any points for your other one. Just so we don't confuse ourselves.
Wait, is it negative or is one doing it?
Okay, so now let's take all of our points and shift them. So we said we're shifting them where? To the right 2. So I take my vertex. I go right 2. I have a new vertex. Oh. It would help if I turn that on. There we go. Okay, I'm going to take this point and move it right 2. I go all the way over here. I move it right 2. It ends up being the same point that I used for my first graph. That's okay. These graphs just intersect each other. So I'm moving all of my points to the right 2 places. I tried to make them a little bigger this time so we could tell which one was where. And then I make my V with straight lines. Goodness. Beautiful. Put my arrows. Oh, I forgot my arrows. And then we've graphed both of them. All right, we need to write some equations. Again, there are just lots of different types of questions you might get asked about these, so we just need to know what we're doing to be able to answer them. Question, or you want to answer?
I wanted to try to answer.
Okay, what do you think on number 10?
Y equals absolute value of x plus 5.
All inside the bars?
No.
I think it should be, right? Left and right, we were always inside the bars. And if we're going to the left, it's kind of backwards of what we think, we add inside the bars. Very good. All right, on the next one, we know it'll be y equals, anybody new want to give it a try? Still some people I haven't heard from yet today. Logan, I haven't heard from you yet today.
Y equals negative absolute value of x
And then we're doing 4 units to the right.
minus 4.
So we would subtract 4 inside the bars. That's all there is to it. We wrote those equations to represent those translations. Okay, so we're going to cut out the graphing part on these examples just for the sake of time. But we will talk about the parent function and how it moves. So what would our parent function be? Y equals the absolute value of x. Okay, now we have 2 different translations happening. Can somebody tell me one of them?
Left, no, right.
Nicholas, what does it mean that I'm adding 1 outside the bars?
Going up 1.
We'd go up 1 unit, so that's one of our translations. Emily, what's the other one?
To the right.
To the right, how many?
3.
To the right, 3 units. Okay, so that means you're taking each point and you're moving it up and over. So instead of just moving it up or just moving it to the right, you're going to do both of those at the same time. Every point would move up and to the right. Okay, so we won't actually physically graph that, but we should. All right, on this one, what's our kind of parent graph?
Y equals absolute
So our true parent is the absolute value of x. I am going to leave the negative out in front here because this one we should remember is still going to be flipped upside down. Charles, what's one translation?
Up 2.
The one outside the bars tells us up or down.
Oh,
So looking at this minus 4 outside the bars tells us we would go where?
down
Down how many?
4.
Down 4 units. Okay. And then inside the bars, Christopher,
Left 2.
we are going left 2. That's the one that's kind of backwards from what we would normally think. Okay, so outside the bars, up and down, intuitive. Makes sense. Inside the bars, left or right, backwards from what we would normally think.
So cool.
What did we get for number 14? Emily?
Y equals x plus 3. Oh, absolute value, and then negative. Subtract 2.
Okay, x plus 3 inside the bars, and then
Minus 2.
minus 2 outside the bars. Okay, so 3 to the left, we add 3 in the bars, down 2, we subtract 2 outside of the bars. This next one, if it says f of x or g of x, that's really the same thing as it saying y. Okay, so we've got negative absolute value bars. What's going on to x inside the bars? We're subtracting 1/2. Inside the bars, we subtract 1/2. That's the right 1/2 unit. Outside the bars, we add 1 to represent the going up 1 unit. The last one, again, g of x is the same thing. It really is writing y equals. Inside the bars, what's happening? Subtracting 7. Outside, subtracting 1. So 7 to the right, we subtract inside. 1 down, we subtract outside.